It is the most devastating twister that exists and can mean total destruction when it hits the ground. You simply do not get more powerful than an EF5 tornado, and it was headed straight for Greensburg, Kansas. And when it touched down on May 4th, 2007, it destroyed 95% of the town, crushing everything in its path from homes to the local hospital, businesses and churches.
It was just kind of sheared off. I just fell on my knees and wept like a little baby.
With the town destroyed, most people thought Greensburg was finished. Since every single building in Greensburg had to be rebuilt, the town leaders came up with an amazing idea: to rebuild the town green. It's a massive undertaking, but if they succeed, Greensburg will be America's first ever eco-town.
We're not just a green community talking about green. A new standard is being created in Greensburg. Everything is sustainable.
From the largest community projects to the smallest private homes, everyone in town wants to go green.
That is not being illuminated by electricity.
No, there's no light bulb.
Greensburg is blazing a new trail, using green elements to build a sustainable future, to build it stronger, and to build it bigger.
In the wake of the tornado, Greensburg lost 95% of their buildings. That means residential, that means commercial, and that also means government. So for example, Greensburg City Hall is now located in this trailer. Right now I'm going to go meet a guy named Steve Hewitt. He's the city administrator and one of the key players responsible for starting this green movement in town.
Steve Hewitt grew up in Greensburg. Then he went away to college and worked for a large city.
Steve?
Yeah.
How are you? I'm Danny Forster.
When he came back home to run the city of Greensburg in 2006, he had no idea how complicated his new job would become.
It's just a massive rebuilding. Every single building has to be rebuilt. Every single infrastructure item has to be evaluated and repaired in some way, from water tower, water lines to city hall.
This is a revolutionary concept. I mean, there's a few green buildings in America right now spread out over, 50 states. And you're proposing in a small town in western Kansas to do the entire town green. I mean, there's no precedent for something like this.
We have one chance to put back this community in the best way, and everything we didn't like, we can make it better, and we can really make it nice for our kids in the future.
To that end, the City Council passed a resolution, the first of its kind in the country. It says that any city building over 4,000 square feet should be certified LEED Platinum, the very highest level of green that you can achieve.
Let's look at this. In America, there are about 15 or 16 LEED Platinum buildings. And in a small town, an agrarian rural town in western Kansas, you might have literally 30% as many buildings, LEED Platinum, as the entire United States of America.
Yep. That's, it's in our name, Greensburg.
It's just fulfilling the prophecy.
I mean,
it was already in the name,
it's
right?
It's right there.
You might as well just follow through with it.
It's our roadmap,
Now, talking about revitalizing, I'm looking at a very, very optimistic pile of dirt.
Well, when you see piles of dirt like this, it means something's about to happen.
Something is about to start.
Yeah. We are going to have a groundbreaking this Friday, LEED Platinum City Hall.
How many LEED Platinum City Halls are in the state of Kansas?
0.
How many LEED Platinum City Halls are in America?
I believe 0.
So this will be potentially the first LEED Platinum City Hall in the United States.
Yes.
City Hall will be a kind of hybrid building, part traditional and part modern, but all efficient. From recycled brick on the outside, to a green living roof, to geothermal heating and cooling underground.
So this will be a green building, but it's going to save you money that'll help you develop Greensburg into a more sustainable and better community.
That's the point that we've always tried to make. Is not green wasn't just about hugging trees and talking about the fact we're just recycling some wood and recycling some brick. It's really about, like you said, green is also dollar signs. And my job as city manager is to make sure that we're doing everything possibly fiscally responsible with the tax dollars in this community. That's what green means to us. Green means dollars. It's really smart use of money.
So Steve, this is the high school?
Well, this is the basically you're on the grade school side of the makeshift modular school right now here in Greensburg.
My goodness, this is school, huh?
This is school.
Every school in Greensburg was leveled by the tornado. But town leaders knew that if children moved to other schools in neighboring counties, their parents would likely move away, and Greensburg would turn into a ghost town. Just south of the temporary school will be the new facility. The east-west orientation of the building and the clear-story windows above will maximize natural daylight year-round. The power for the school will come from a 300-foot-tall wind turbine. The windows and open spaces between the buildings create natural ventilation. The opening of this amazing new project is set for the fall of 2010.
Those visual things like a wind turbine are something we like to show because it shows, hey, you can actually see the energy produced for that school.
I mean, the kids in the classroom, apart from seeing their skylights and seeing their solar panels and breathing in that fresh air that's brought in, they're quite literally out the back of the school going to see this spinning turbine powering their lights.
Absolutely.
So the building has an interactive quality to it where they're not just sitting there learning in school, but the building itself is demonstrating what it is to be a green building.
Right.
The next generation of Greensburg students will be learning about sustainable ideas and doing so inside a sustainable building. And the whole country will benefit by their example.
Now, the person responsible, the lead master planner in helping Greensburg visualize their dreams is a man named Stephen Hardy, who just so happens to be a master planner and a buddy of mine from grad school. How are you?
Danny, good to see you.
Did you think that we'd ever end up meeting in Kansas after being in grad school in Boston?
Western Kansas, no less.
Rural.
Here we are.
Rural Western Kansas.
It's a little bit more of a stretch for you, probably.
You're actually from here, right?
Yep. I grew up not too far from here.
So tell me a little bit about how you got involved in Greensburg.
Well, shortly after the tornado, actually the governor's office came into our office and said that there was this little town that was maybe wanting to go green and they needed to recover from a disaster and asked us just to help out.
So you were literally asked to begin from the ground up.
It is true, and it's not quite as much of a blank slate though as you might think right up.
How do you mean?
All of the infrastructure is still here underground, but more importantly than that, property ownership is the same, and people's memories of what was here is exactly the same.
What were the first steps in helping them understand what they had to achieve? In other words, you're not going to build this typical metal building.
Right. When we were talking about people wanting to rebuild as fast as possible, that was the solution. Put up a Butler building and we'll be on our way. Right away, they latched onto the term 100-year building. They wanted to be building buildings that were here for the next 100 years. In 5 years, you're going to see all of the civic buildings back up. You'll see many of the commercial operations back up and running. You're going to be seeing eco-tourists in Greensburg.
So, Stephen, this is the master plan you presented to the town.
Yep.
And this is, I guess, a vision of what Greensburg could look like 5-10 years from now.
Yep.
So take me through some of the main goals, so the aspirations of this master plan.
One of the things that the community established really early on is that they wanted to reinvest in downtown in a really significant way.
And that's what I'm looking at right here.
Yeah, right, running north-south, right through the middle of town.
And that's the only traffic light in all of town.
That's the only stoplight, yeah.
Okay, so for you guys, that was an important node to develop to kind of help them build back Main Street.
And it's the connection between all the traffic that's going through town and then all of the businesses that are on Main Street.
So getting the business incubator up on that corner was a key planning decision.
That, and it's also a sign to everybody that Greensburg's coming back.
The tornado that hit Greensburg on May 4th, 2007 blew away homes, destroyed businesses, and public buildings. It even took down the building that you need most after a disaster, the hospital. At nearby Kiowa County Memorial Hospital, that night, staff had moved their 20 patients down to the basement when the storm warnings first came.
We had a basement, and we always said it was the safest place in town because it had a cement floor above this basement. We knew it was going to be a safe facility.
Even though Hospital Chief Mary Sweet was in Topeka that night, the staff followed her disaster plan to the letter.
So all the while your staff is braving this tornado, not knowing what's going to happen, they're actually acting like nurses and doctors and taking care of these patients.
Correct. And the tornado hit at 9:45. At 11:02, I got a phone call from my lab director, who was at the facility. He got a cell phone. It was real sporadic that night. After the tornado, the cell phone towers were gone. He somehow got a 2-minute call out to me that said, "We're safe, but we're stuck in the basement."
Although they were stuck, they were safe and unhurt, allowing rescue workers above ground to concentrate on pulling other victims from the rubble first. By 3 a.m., the staff and patients of the hospital had been moved to another location. Like practically every other building in town, the hospital was destroyed.
Okay, so over a year ago, you lost the hospital.
Right. We lost the whole facility.
It was gone.
It was gone.
So what do you do? I mean, how do you get a hospital quickly to a town that has sick and wounded?
Well, if you'd asked me the day after the tornado, I would have told you I have no clue. But we had incident command meetings, and everybody coordinating the disaster was at these meetings.
Right.
And they asked me what I needed, and I said a hospital. I actually thought it was a joke when I said, oh, I need a hospital. And the Adjutant General's office had a representative there. And he said, I can get you a hospital. Give me 15 minutes. Got off the phone, said, where do you want it? I can have it here as soon as you want it.
What Mary and Kiowa County got was basically a mobile military hospital, like what you'd find in a MASH unit.
So this isn't just like a MASH tent like on TV. This is actually a real hospital, meaning all your radiology equipment, your CAT scans, MRIs, beds, all of that comes with this.
Correct.
So it's like a hospital that arrives on site.
Right. And they can set it up, and you just have to put staff in there.
Just 2.5 weeks after the tornado, Greensburg's temporary hospital was up and running. And it wasn't long before plans for a new sustainable hospital were underway. But building a hospital green is more complicated than you think.
So now I'm at the on-site construction trailer for the Kiowa County Memorial Hospital. And standing right here is actually the architect of the facility. Tim?
Hi.
I'm Danny Forster.
Good to see you.
Good to meet you. So you're the architect, the lead architect of the project.
Yes.
So this is not just any project. This is the first ever LEED Platinum rural hospital in Kansas.
That's correct. In fact, actually, it's the first critical access LEED Platinum hospital anywhere.
In the country?
In the country.
Now, for me, what I find really fascinating is that LEED certification and hospital design don't necessarily go hand in hand.
No, they use a lot of energy, and that's just necessary because of the processes and the things that go on in the hospital.
So things like X-ray machines and MRIs and all the germ control, all that stuff has a huge energy load.
The germ control is one of the biggest things.
Yeah.
We have to be very conscious of where the air comes from, what possible pathogens might be air-laden into the air.
And then
we have to get those out of the building. So every cubic foot of air that we take out of the building, we have to bring new air in. So all that has to be heated or cooled. That takes a lot of energy.
Daylighting, right? LEED wants you to daylight each and every space for all employees. But in a hospital, you can't necessarily do that.
Notice the way the north side of the roof reaches a higher peak. That allows the south-facing windows to run the entire length of the building, directly above the main hallway leading to patients' rooms. The natural daylight those windows deliver will minimize the need for artificial lighting.
It's been studied that if the space is designed well, if it's a space that people enjoy being in, then they actually heal faster than if they're in the prototypical green square box. This area right here is actually what we're calling a healing garden. Mm-hmm. It's a plaza space. It's directly accessible from the patient area. As soon as they're able to be ambulatory at all,
right,
even in a wheelchair, they can come down this corridor and straight out into this walkway that traverses around this pond on the site. So it gives them a place to walk, a place to enjoy the outdoor space.
There are two kinds of water collection going on here. When it rains, water that falls on or around the building is filtered into underground collection systems that can hold up to 24,000 gallons. Water gathered there is used for irrigation. Gray water from the hospital is sent through a natural filtration system, then into a retention pond. That pond is part of the hospital's healing garden, where patients and visitors can enjoy the fresh air and tranquility.
And what's so fascinating is that you're using this pond right here, which is an actual natural occurrence where you're literally using to drain the water away from the building to create a healing landscape feature.
Absolutely.
So this is an environmental opportunity. So there's no difference really between the life of the building and the life of the green systems.
Well, and it all ties back to the patient. What's going to help the patient enjoy the stay, heal faster?
That's great. I hope not to get sick, but if I do, I'm going to come here and I'm going to enjoy, I'm going to heal more quickly.
When the tornado struck Greensburg in 2007, it wasn't just the homes that blew away. There were also no basic necessities that you take for granted every day. Gas stations were gone. Convenience stores were lost. Restaurants that had been around for generations were flattened. Even the town's only supermarket, Dillon's, had to start over from scratch.
So this is the Dillon's Quick Shop, and it was one of the first buildings built back after the tornado. It's a gas station, it's a convenience store, but it's really been like the epicenter of commerce here in Greensburg. If you're hungry, you get a burrito in there. But not for long. The good news is, at long last, there's gonna be a Dillon's supermarket right next door. And the amazing thing is, because this is Greensburg, check it out. ICF Construction. It's gonna be a green supermarket.
ICF stands for Insulated Concrete Forms, basically hollow styrofoam blocks that are stacked and then filled with concrete and rebar. An ICF wall can stand up to tornado force winds and cut your heating and cooling bills in half.
I'm in Kansas City, Kansas, which is about a 5-hour drive from Greensburg. And it's here where they're building one of the new technologies that'll form the new Greensburg. It's called ICF, Insulated Concrete Forms, and it's all being built right here. This is the raw material.
Right, this is our raw material. What this is, it's a plastic ball which contains pentane gas. We're going to introduce steam to that bead, and two things are going to happen. One, the exterior of that bead is going to soften because of the heat. And the other thing is that the pentane gas is going to expand.
So basically, we're going to pop this like popcorn. In the end, these small spheres will then be larger spheres.
That's right.
All right. So we're going to dump this into the hopper. The hopper will then suck the small pentane gas-loaded little spheres into the expander.
That's right.
So right now, the resin has now been inserted into the expander. What's happening?
Right. Right now, what we're doing is 10 pounds. Take 10 pounds of resin, we expand it, we evacuate it, then we go into another 10 pounds.
Oh, look at this. Oh.
Out of the expander, we put it in a storage facility, and we let the material equalize.
So in these massive containers,
Right.
this is all full of the expanded beads. And there they are. My very EPS beads, having relaxed for 12 to 15 hours, are ready to go. They're ready for the big show. They're getting sucked from that big bag, going through this tube, then shot up this pipe, through the ceiling, into the plant where they'll go into an injection mold and become an ICF block. There it is. And there we have it. 6, can I see that? It's still warm, ow, it's still extremely warm, and it's wet from the steam, and this is it. So you can see, literally, you can see the different beads right there, fused together. So how many of these can come out of this machine each and every day?
We can run about 480 pieces per day.
480 pieces a day. So to put that in perspective, for a sort of a modest, say, 1,500 square foot house, that's a house.
Roughly.
And that's it. You got yourself a structurally thermally insulated green ICF panel. Whew.
These days, ICF blocks from all over the country are making their way to Greensburg. It's one of the most common building materials in town. Like the new First Baptist Church across the street from Dillon's, where Pastor Marvin George is taking biblical references to good stewardship of the earth very seriously.
Pastor Marvin, how do you get from where you were before to now a almost 9,000 square foot facility built out of ICF forms, which is, I'm sure, not what the old church was built out of?
We remember the old utility cost that we had. $800 or $900 up to $1,000.
$1,000 each month to heat and cool the thing.
Right. Traditionally, churches are the absolute worst in energy inefficiency, just because they're the least used building on the block and they consume most of the energy. And when we was going into this, we said we want to build this right. We didn't want to send all of our money to the utility companies. We wanted to use our money for ministry.
So, Pastor Marvin, this I assume is this is the front door.
This is the front entrance. Yes, it is.
So take me through what I would see as I come through the threshold. I walk into the church. What am I looking at?
You're looking at a foyer hallway with the main sanctuary to our right, fellowship hall, office, restrooms, and stuff on your left-hand side.
So basically you have this central spine which looks right through to a window, which is fantastic.
Another door.
So you'll have light basically on both sides.
Right. Yeah.
To my left you'll have the sort of the back of house functions.
Right.
And then if I were to make a right, this is really what it's all about.
Yes. like to talk to you about this architect piece over here on the east side of the wall. The cutout there on the wall, and then the wall is set back 3 to 4 feet.
Yeah, I noticed that.
And there will be 25 to 30 feet of glass on both sides, one to the south and one to the north, and that will allow natural lighting to come in that direction from the sanctuary, so we won't have to use any lights on Sunday morning.
So no need for additional lighting because you'll have enough light.
Right.
No need for additional air conditioning because you won't have the heat.
Right.
And it'll be just a gorgeous sunny place to look
setting.
at.
Yeah.
That's just good thinking right there.
I thought so too.
To create an incredibly tight, energy-saving building that still looks like a church, the sanctuary will have exposed wood arches every 10 feet. The ceiling above those arches will be made of structurally insulated panels, or SIPs. SIPs panels are made with 2 pieces of plywood. In between that plywood is a layer of non-toxic polystyrene foam. Those 3 layers, when sandwiched together, create a strong material that provides framing, insulation, and exterior sheathing.
So this is a really tight building.
It'll be really tight. If we can heat it with a candle, we will.
Did you ever think that you'd be the pastor of one of the first green churches in the country?
No, that never ever crossed my mind. This is really cool. I'm really excited about this, because biblically we are supposed to keep an eye on the resources and the gifts that God has given us and to use them wisely. And lessening our footprint on the environment is a very key element of that.
I'm in FEMA town. Right now I'm going to go meet a family called the Anglicans. They're a family that, like many Greensburg residents, had a house, had a home in their community, and now it's gone. And this is what they've been calling home for the past 11 months.
It was getting dark then, and the kids were busy getting the animals down the basements and stuff, and then it started hailing. Real big hail. I mean, it was probably 3 inches in diameter.
But as soon as it got quiet, he said, "Get ready, we're getting ready for the storm." And that's what they usually say, it gets real deathly quiet before the tornado hits, and it did.
And it was just like a bomb went off outside.
You could just hear everything just tearing up. I mean, it was just tearing up and breaking things and glass shattering and all that noise and stuff coming down the stairs. We ended up with a deep freeze at the top of our stairs. It was our neighbors. After it was all over, it felt good to know that it was finished, even though you had to go up and see what there was.
Their house flattened like others in town. The Anglicans decided to rebuild, but as long as you're going to build something new, may as well be green.
On the football field.
Well, hi there.
Hey, how are you?
Hey, Dan.
It's been almost 13 months in the trailer, right? So is it, I imagine there are moments where you think to yourself, this is just not going to happen. You're looking at drawings, it all seems less like a dream. Then when you start to see a bunch of guys digging a hole, does it sort of change for you in your mind a little bit?
Oh, yeah. It's reality's coming now. You can talk all you want and see all the pictures you can see, but after a while, it's like, it's not going to do it until I see them start going.
And then probably, in about 3-4 months' time,
The house.
you're cooking dinner in your house.
Yeah, I can't wait. That's the biggest thing I like to do, have a big kitchen, so that's really been bothering. Yeah, he likes the meals. If I have a bigger kitchen, I guess he thinks I cook better.
In a normal stick frame house, all the different trades arrive on the site one after the next and bring their materials. So the masons bring the concrete for the foundations, then the framers bring their wood to build the house, then comes the building paper and the insulation, and so on and so forth. The incredible thing about ICF construction insulated concrete forms is that all of those different building products are on site, check this out, from day one. And if you can believe it, all those different materials, from the structure of the building to the thermal barrier to the building paper to the studs, all those products are embedded right here in each and every block. Let's go build a building. Now, how do you build a wall? Well, they really do call it Legos for big boys. It's that simple. You'll see each piece has a series of ridges which act as studs, as well as this toothy side. And one side has a his and her and fits right into the next. They meet together. So check this out. You line up your studs, the teeth on bottom line up, and then with a simple tap, your wall's in. I mean, it's literally that simple. Now, these pieces right here don't just mate one piece to the next. They also perform an additional function. You see, there's no building paper on this building, what we call a vapor barrier, to keep water and moisture from seeping into the wall. Because what happens is, you can imagine a little drip of water is trying to get in here, it gets stuck. If it gets through here, it's stuck. It's a series of small vapor dams that keep water from penetrating into the wall. So that's one product, building paper, that's now been removed from the process. So once the wall is lined up tight, you put on your other piece of ICF. It's simply as easy as lining up your pieces, and that's it. So now you have two pieces of ICF wall, both the outside and the inside of the building. And the way you're going to hold these things together, so when the concrete goes in, the wall doesn't bow out, well, use your struts. Very straightforward, very simple. And watch this. It's all about the technique.
When you live in a place called Tornado Alley, you have to think about every wall, window, and door of your home and how it'll hold up during a storm. One of the designs that the Anglicans are looking at calls for a tremendous number of windows. Now that could cause a problem if you used traditional glass, but not if you install the nearly indestructible material called Century Glass. And I've traveled to a materials research lab to test glass, to find glass that is impact resistant enough to last through a tornado, but it's also green enough to work in Greensburg. Check this out. Hello.
Hello there.
I'm Danny.
Hi, Danny. I'm Valerie.
So you are a glass specialist.
Yes.
Tell me then, how do you get a piece of glass which provides you transparency, which brings in natural daylight, but also acts as a shield or a barrier from flying debris?
If you use impact-resistant material as part of the glass makeup, if the glass should break, it will remain integral in its frame after breakage.
So let me get this straight. This is the polymer right here, right?
This is the polymer,
So
right.
this is what's inserted inside two panes of glass.
Correct.
And so you're saying during a tornado, a rock is flying 200 miles an hour, flying around, it smashes into this wall. The outside layer of glass will shatter. Maybe the inside layer might shatter, but you're saying this polymer will remain intact.
That's right.
You're saying I could hit it with, say, I don't know, a bat?
I think you should try.
Safety first?
Safety first.
$50 I can take this thing out. That's amazing. Can I do that again?
I think you should. Give it all you got.
Ready for this one? This is a big one. Ready?
Another one.
Ready? Here it comes. Here it comes. Didn't break. I mean, it just, no matter how hard I hit it, this thing does not break. This is a brand new aluminum bat, and after a couple hits in the glass, I've literally bent the bat. That polymer just bent a metal bat. That's an endorsement. That's impressive.
The Anglicans' basement survived the 200-mile-an-hour winds from the tornado that hit Greensburg in 2007. Now we hope another tornado never comes anywhere close to this town. But if it does, the Anglicans' new home won't just have a basement, it'll have something called a safe room.
In Rick and Rhonda Anglicans' new house, they're going to have a storm shelter, but it's not going to be in their basement. Their safe house is actually going to be their walk-in closet.
Hello.
How are you?
Hi, Danny.
Nice to meet you.
Good to meet you.
So what makes this safe during a tornado?
What we have done here is we lined all the walls with Kevlar.
So you've wrapped this building in what is basically a bulletproof vest to protect it from debris.
Correct. So as you can see, this is a normal closet.
The safe room will have panels reinforced with Kevlar.
Close the door.
Pound for pound, Kevlar is 5 times stronger than steel, and it's incredibly flexible.
This is the steel framing that goes around the room and makes it crush resistant. And they're bolted into the foundation every 18 inches.
The storm shelter / walk-in closet has an amazing set of features. You have the steel, you have the Kevlar, you're bound to the foundation, but ultimately, I mean, is this thing going to protect them?
Absolutely. You want to go find out?
This is exactly what a typical wall would be in a house. You have vinyl siding, building paper, insulation, wooden studs, and sheetrock.
And so what we wanted to show is what would debris look like when it hits this kind of typical construction.
Okay, so 15-foot
2x4. So Chris, with the 2x4 loaded in, we're about to fire this 2x4 at 100 miles an hour into that wall.
Yeah, this simulates F5 tornado conditions right here at this speed of this 2x4 traveling.
Let's do it. All right. This is what happened 1 year ago in Greensburg. Oh my God.
Went right through it.
That says it all. I mean, look at that. So you're not safe behind a wall. What about a steel door?
What about steel door? We'll put it up there and see what happens.
Steel on both sides, wood inside.
Yep.
And people think, well, I'm behind a steel door, locked it up tight. During a tornado, I might be safe. In 3, 2.
I think that door would hold up to that. Ripped right through it.
But I could imagine someone making the argument that a CMU block, a masonry house, might be safe. Typical CMU concrete block.
You want to load up the cannon?
Let's do it. 3, 2, 1. Oh, the CMU block just got hit and exploded. One last thing we're going to test is Rick and Rhonda's walk-in closet. So finally we're going to find out if this new storm shelter wall will keep them safe during an F5 tornado. In 3, 2, 1.
Bounced right off.
So basically that 2x4 just shot at 100 miles an hour, made impact with the storm shelter, and bounced right off.
This is your safe haven.
If you're going to have to go through a tornado, a nearly 2-mile-wide tornado is heading right for Greensburg, Kansas. Hundreds of people head for their basements, hoping for the best.
I knew it was different, and I don't know why. And
Farrell Allison, his wife Debbie, and his elderly parents make their way down the stairs. What they leave behind upstairs is a perfectly restored and furnished Victorian home. That's not what they'd find just minutes later when they emerged.
I didn't really get scared until the boards started coming in the basement windows. And as stuff started coming off of it, the roof going off, all I could think was, this is going to be a big job to fix this.
Well, it was bigger than you could fix.
It was much worse. Yeah.
Our house did good for us.
The house did protect them, but was damaged beyond repair.
There was just stuff everywhere, and it was all filthy, and I walked in my living room and I picked up a pillow. I said, this isn't my pillow. Where's this stuff come from?
And the rug, too, that was there, that wasn't ours.
I know all kinds of stuff that wasn't ours.
Farrell and his wife soon faced up to the fact that they were going to have to rebuild. He's an agronomist, which means it's his job to help farmers manage soil use and crop production. So for him, sustainability was instinctual. And making his home the greenest in town came naturally.
The world of sustainable design is a relatively new field. You have new materials, you have new technologies, and you have a whole host of new professionals whose job it is to build green design. Now, what happens if you want to rebuild one of the simpler things in life, like your own home? And what if you want to do it without the help of FEMA or any of these new professionals? Today I'm going to meet a guy who's decided to stay in Greensburg and rebuild his home. But he's going to do it by himself, designing it himself, building it himself, and teaching himself all the new sustainable technologies. And he's going to accomplish this entire goal with him, his wife, and his son. Come on. Hi there.
How you doing?
Hello. How are you? I'm Danny.
Farrell.
Farrell, nice to meet you.
David, nice to meet you.
Hey, dude. Father, son?
Oh, yes.
So where's the contractor? Where's the architect?
He's all right there.
Right here.
So you guys are doing this yourself?
We're doing it ourselves.
So Farrell, take me through this house a little bit, because this is the first house you've ever built on your own. You guys essentially designed the house yourself. And you did all of this with the idea of sustainability in mind.
Right.
When it comes to sustainable design, Farrell has a slight advantage. You see, before his career in agriculture, he actually studied a bit of architecture. So out of the tragedy of May 4th, came a chance to try his hand at his second career choice.
That's not a traditional skylight.
No, it's not. It's a tube skylight. Very highly reflective inside. It's got a dome over the top.
So this is a solar tube.
It's a solar tube.
So you basically have essentially like a skylight on the roof.
Right.
We have about 15, 20 feet of mirrored tubing, which then terminates here to this amazingly bright light here in the kitchen. That is not being illuminated by electricity.
No, there's no light bulb.
So that incredibly well diffused light is happening just because the sun's coming down a tube.
That is exactly right.
I mean, I hate to say it, obviously the tornado was a horrible tragedy, but in many ways it's sort of pushed you to actually do a lot of the things you've been thinking about for years.
There's nothing that happens that doesn't have something good in it. You know, there's always, you can always find something good.
One of the elements that make Farrell and Debbie's house just so green is something called geothermal heating and cooling. As the name implies, geothermal uses the Earth's constant underground temperature to reduce the workload on traditional climate control systems. In the case of their new home, the Allisons drilled 3 200-foot deep wells. Liquid is pumped through those wells, bringing its temperature to 55 degrees. Geothermal technology will be used at many new projects in Greensburg, and the bigger the building, the bigger the dig. For example, a 10,000 square foot commercial space on Main Street has 21 wells. Since the tornado, about 170 new homes have started construction in Greensburg, and the Allison house is the greenest of them all.
I'm kind of competitive, so it'd be nice to be the best one.
Well, I'm now back at Farrell Allison's house, and as you can see, they're making some progress. Siding is on. I'm going in to hang some wallboard. Look at that. JJ,
That's it.
you're like a ninja. All right, so guys, what we just did over there was hang wallboard on a totally traditional wood stud wall. Put the wallboard up, screw into the studs, call it a day.
Yes.
What's the difference when you start working on ICF, basically a green wall?
Well, this is styrofoam over concrete.
Right.
And then they got little X's here.
And this is where the metal studs are?
Yeah, the plastic
studs?
Little plastic strips.
So you can see right here, 8 inches, 8 inches, 8 inches, 8 inches there.
Yeah, and also on these, you got to go through and you need to mark them on the floor and the ceiling so you'll know where they're at.
Those are 16 on center. These are 8 inch on center, right?
Right.
So this actually is a little bit easier in some ways, right?
Well, as far as hanging goes, it's harder.
Why is it harder?
Because you got to hold the sheet and put screws in at the same time.
Can't nail into this stuff. No nails.
No, other than where the wood is.
So the nails won't hold in here. You'll rip the styrofoam.
Yeah, they will not go through it.
So is this one of those moments where the green technology helps the house with insulation and structural, but in terms of actually the mechanics of building the house?
It's just a little bit harder.
A little bit harder.
Yeah.
So what I'm doing right now is marking the location on the ceiling where those plastic studs are, so when the wallboard finally goes on and we can no longer see it, we'll know exactly where to screw the stuff in, and knowing every single time we'll be connecting the wallboard through the styrofoam into the plastic stud buried against the concrete.
Watch out for the glue.
Yep.
And we'll slide it on up and go all the way over.
All the way tight to the wall. Yep.
And hold it up tight against the ceiling.
Yep. Oh, line. Got the best of me.
Okay. Kind of snap it, and then it's done. You just set the nail, and then you hit it 3 times, and it should be set.
Set it once.
Yep.
And then 3 hits.
Yep. And if you're really good, you can just do it, just set it and then in one.
So much for nailing down the sustainable aspects on the inside. There's also a lot of work to be done on the outside, specifically siding.
Now let's be clear, that's not wood that we're putting up there.
No, it's not.
What is it exactly?
Fiber cement.
So it's a fiber cement board.
Yes.
So instead of using wood or cutting down trees to have traditional shingle siding, this is a kind of a cementitious artificial product.
Right. It holds paint very well. The company that I bought this from, 20-year guarantee on holding paint.
So in terms of sustainability, one of the opportunities with this is that unlike wood, where you have to put on a chemical sealant, then put on a paint, and then every 4 or 5 years you have to reseal it or repaint it, once this is on, this is that hardy plank, this cementitious fiberboard. And typically, when people are putting shingles on a house, it'd be cedar shingles or wood shingles of some kind. But this stuff, as you can see, it has a kind of a faux grain of wood, but it's actually made of powdered cement and a binding agent. So the aspect of green that this brings to the table is low maintenance and material resource.
Pretty level, isn't it?
I like that.
Okay.
All right, screw gun. A lot of folks don't do this every day.
No. But I cannot wait until this house is done and I can go out on my screen porch with my breakfast and say, I don't have anything to do today.
Just able to sit in your kitchen, have a coffee, and look out on Greensburg.
That's right.
So this gives you a sense of really just how challenging it is to try and accomplish a truly sustainable house that considers these issues on each and every level. So for example, Farrell has taken the time to think about how this house is sided for passive cooling and passive solar. He's used ICF block construction. They have rapidly renewable bamboo floors. They have 2-button flushing toilets. They have water reclamation cisterns. They have landscaping that needs no water. They have siding that's cementitious and therefore doesn't use wood. They have solar tube lighting. Literally every aspect of this house takes into account sustainability. And you know what? It can be done. Green design means green building and longevity. And this is one of the greenest houses in Greensburg, Kansas. My time in Greensburg is up. I've been here for about a year, and I have to tell you, it's been incredible. As an architect who builds green buildings for a living, it's really inspiring. You know, we're starting to see more sustainable design popping up across America. But nowhere have I seen one town come together to make this kind of commitment at this level. And the amazing thing is, they're doing it. They're not just talking about it. I mean, if you look behind me, this is just a year and a half's worth of progress, and it's only going to get better. So I'm going to come back and check out the progress, and I think you should too, to both support and celebrate what this town is doing. This is America's first ever LEED Platinum town. This is Greensburg.
接下来，你能及时行动吗？任何事都该有爆炸性的结尾吗？解谜小组回归到文字的本意，为你剖析经典名言。留言终结者接着播出。